Before the analysis of your trajectory, you must define which parts of your system you are interested in. In this video I am going to cover the traditional static way of doing this using GMX make and DX program. Another way to analyze your trajectory provided by GROMACS is to use GMX select program to make dynamic selections based on the geometrical properties of your system. For instance, you can select all the atoms within a specific range from your ligand or the residue of interest. GMX select cannot be considered as a direct replacement of GMX make and DX, as these two tools serve different purposes and you can combine them to achieve the desired result. Therefore, this educational video on how to use GMX make and DX is still relevant. GMX make and DX requires you to provide the input file with coordinates or the index file. Although they both are marked as optional, you still need to provide at least one of them, otherwise you will get error. You also must provide the output index file in which GMX make and DX will write your newly created index groups. Once you start GMX make and DX program, you will notice a list of groups which have already been created by GROMACS. Using GMX make and DX limited vocabulary, you can manipulate those existing groups or create entirely new one within the atom range of your system. You can list the residues in your system by entering L. Although both atoms and residues can be used to create index group, using residues is usually much more convenient. Besides 22 index groups which have already been created by GROMACS, my index file also already contains 5 groups which were created by myself. Those groups were loaded from the index file, which I specified as an input. To select specific atom, type A space and atom index. Press enter to see the updated list of index groups with the last group consisting of the only one selected atom. Selected atom is one of the protein atoms, which are the first 13,279 atoms in our system. This automatically makes our 27th group a part of the system group and the protein group. Think of each index group as of a set of indexes which can overlap with other such sets or even exist within other sets. Among the most common operations a GROMACS user will perform on index groups are merging them and subtracting one group from another using symbols not and or. You can select atoms of the specific type by entering T space and the type of atom. You can use wildcard symbol to account for various similar types of atoms. In this particular case, I have selected all the hydrogen atoms within the system, including both protein, ligands and solvent molecules. In total, 52,997 atoms were selected. Let's rename this group to make it more human readable. We can do it by entering name keyword space number of the index group which we want to rename space and the new name of the index group. By subtracting hydrogen's group from the protein group using not and symbols, we can obtain the protein -H group. Now let's select all the alanine residues in our system. We can further split our newly created alanine residues group by using split res keyword space and the number of group. Now we have confirmed that indeed alanine residues group consists of alanine residues from both of protein chains currently present in the system with different residue numbers specific to each chain. using residue keyword with or symbol, let's create a group of residues which contains only planar cyclic residues, phenylalanine, tyrosine and tryptophan. Now it should be clear that each residue of the splitted group has the group name preceding the actual residue name and the index number. Let's clean this up a bit by removing all the splitted residues from our index groups. You can do it using del keyword space and the number of group or the range of groups which you want to cover. In a similar way, you can select a range of residues from your system. If you have more than one chain, you can use split chain keyword with the number of index group to split its atoms into two different chains. You can do it with any index group containing any number of atoms from different chains. Besides split chain and split res keywords, there is also a split add keyword which allows you to separate index group into atoms that are included into this group. Each of the names of splitted atoms contains the name of the group, the type of an atom, and the number of an atom. Use keep keyword to delete all groups except for the specified. Enter Q to save your current index file. Index group file has a simple format. It is a plain text file with index groups where each index group starts with a header in square brackets. After that, there are atom indexes listed with spaces between them. Thank you for your time and let me know if you had any troubles.